Hello, everyone, and welcome to today's SANS webcast, Terraforming Azure, Not as Difficult as Planets. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is David Hazar, SANS analyst, instructor, and course author. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to David.
Thanks, Carol. Good morning, everyone. As Carol mentioned, my name is David Hazar. I've been working in technology for around 20 years now. I started out as a developer, but working for small to mid-sized organizations means I wore a lot of hats and had a lot of different responsibilities. And so I've been able to gain experience in a lot of different areas within technology. This eventually led me to focus on security. You may have heard the term jack of all trades, master of none. That's what I would have been known as back then. But in recent years, people have come to see the value of a more diverse skill set. And so as we've seen this shift towards DevOps and full stack engineers, luckily my skills are now appreciated. Before deciding to do my own thing at the end of last year, I worked as a senior manager for Deloitte, leading the delivery of their secure DevOps and vulnerability management offerings. I'm a co-author and instructor for the new SANS course Management 516, which is all about vulnerability management both on-premise and in the cloud. And that runs for the first time in a few weeks in San Francisco and is 50% off for the first run. But I'm also an instructor and contributor for Cloud and DevOps Security Automation, which is why I'm here to talk to you today about Terraform in Azure. As you can see, the DevSecOps curriculum has a wide variety of courses in application security, DevSecOps, and cloud. And more detailed descriptions of those courses can be found on sans.org. Let's get started with an overview of Terraform. Terraform is an alternative to using cloud-native infrastructure as code technologies like Azure Resource Manager, CloudFormation, or Google Cloud Deployment Manager. Infrastructure configuration files within Terraform are written in the HashiCorp configuration language and can be used to define application environments or really an entire department's or company's organization, entire department's or organization's infrastructure. Once the configuration is defined in the configuration files, Terraform can then generate an execution plan. And that execution plan shows the changes which will be made to the infrastructure or services and then apply those changes. Now, obviously, once we apply those changes, the environment could change. Hopefully it's not changing, but if it does change, Terraform can analyze those changes and generate execution plans that will make modifications to bring the infrastructure back to the defined state. The code that organizations write can be managed like other code. It's code, so you can put it in your version control system, whether that be Git or SVN or some other option. And this can help provide some rollback or recovery capabilities and also enable you to audit who's making changes to your infrastructure, which is very hard to do in a more traditional environment where you're not writing infrastructure as code or configuration as code. It can also integrate into your code review processes, and this can help enable separation of duties between those developing the infrastructure as code and those who are approving deployment to production environments. You can have some people that are part of that review process to make sure that the code is reviewed before it goes out into production. There's support for input variables which allow us to abstract some of the infrastructure as code properties, and that way we can set those dynamically at runtime and leverage the templates across different applications and different environments. Also, we can destroy or tear down the infrastructure based on what's defined in these configuration files. And I'll walk through some of the basics of these configuration files and then do a short demo as well later on in the webinar. Terraform is different from the cloud vendor provided infrastructure as code capabilities because the language and syntax for creating resources, data sources, variables, outputs, all of the different configuration is the same across cloud, but also other service providers that we'll talk about later. And this enables organizations to focus on hiring and developing talent that understands one language and syntax versus having to, if you're in a multi-cloud environment, have a different language for each provider and have to have resources that know and understand those languages. While the language and syntax is the same, that doesn't mean that you can use the same code to create a virtual machine in Azure or an instance in AWS or a compute asset in Google Cloud. So the cloud providers have different required properties and prerequisites which need to be set before resources can be created. And in order to do that, each provider has a provider or plugin that is used to support resource analysis, creation, and change. What that means is the resource type that is used for creating an EC2 instance, which is called AWS_instance, is different from the resource type that's used to create an Azure virtual machine, which is Azure RM_virtual_machine. And that's all available in the Terraform documentation, and you can look up the various providers and see what resource types they support. While you can't use the same code to define resources, you could configure resources across multiple cloud and service providers in a single configuration file or set of configuration files. And then you can parameterize those using input variables to target different cloud or security or service providers when you do your deployment. Another helpful feature is the ability to import existing resources. When you're getting started writing your infrastructure as code, you may want to define and manage environments that already exist. And by defining the appropriate providers and then having at least a shell or empty code block for each of the resources in your HCL or HashiCorp configuration language, you can then import the existing resource. And again, we'll go through an example of this later. Once the resources have been imported, you can compare the state files, which are labeled .tfstate in the directory where you run Terraform, or you can do these remotely, and we'll talk about remote state management later as well. So that once you import it, all of those properties are found in these tfstate files, and then you can use that information to help you generate the rest of the required properties and things that you need to get into your HCL configuration files. Once you have your configuration files built out, you can run Terraform plan to determine if the resource is defined correctly. If it's defined correctly, then it won't try and recreate or change that resource. If not, then you'll see that it's still trying to recreate or change that resource, and you'll know that you're missing some required properties or something's not matching the resource that exists in your environment. It's also possible to define data sources, and what these are basically read-only resources. So data sources will leverage the APIs of the cloud provider to read information about a resource that exists without making changes. Because some of the services and technologies are the same, whether or not you're hosting them on-premise, on AWS or on Azure or elsewhere, you can define the configuration once and use that same code across infrastructure and cloud providers. I mentioned before, you can't do that. You can't just create code and then deploy it to any cloud provider because there are different providers for each cloud vendor. But for instance, if you create a Kubernetes service on each of the different cloud providers, then you can use the Kubernetes provider, which is a separate provider, to manage all of those services across all your cloud providers. And so depending on what you're doing and what provider you're using, there might be some ability to share that across cloud environments. Terraform operates using file-based state. When it analyzes the environment, it stores the acquired information about the state of the resource in those tf state files that I mentioned earlier. These files are stored locally, just in the directory in which Terraform is executed by default, but remote state management is available and encouraged, especially for those organizations where they have multiple engineers working in parallel. And some of the options for that would be S3, DynamoDB, Azure Storage, Artifactory, and then Terraform Enterprise obviously also has a remote state management capability. When you're looking at what to use for your remote state management, take a look online. It'll tell you which ones support file locking and things like that that you're going to need that you're probably going to need if you're having multiple engineers working on the same code. When provisioning resources, you may need some resources to wait for other resources to complete before they can be provisioned. And Terraform supports both implicit and explicit dependencies. However, it may not always have visibility into the progress of installation, initialization, and configuration of applications and services after resources are created. So you may need to add wait conditions or force resources to wait for a database to initialize or for applications to become available. And in order to do this, you can leverage null resources and provisioners or external data sources. And then you can run scripts to inject time delays or to query the status of the application or service, waiting for it to become ready for those dependent resources. In some cases, Terraform does not have support for new APIs or services from your cloud providers because they've got to develop that support once the cloud provider releases the APIs. And so organizations may need to create their own providers, and this is where, again, you would leverage those null providers and resources. You could also use the cloud provider's native infrastructure as code capabilities, and Terraform can still manage those, in this case of Azure, the ARM templates. Just realize that once you can deploy that ARM template, but you lose track of those resources. If changes happen in the environment, it's managing the template, it's not managing those resources. You know, it's best to rely on the Terraform native resources, but again, if it's a brand new service from the cloud provider, you may have to wait for some time before those native capabilities are available. Some of the cloud provider infrastructure as code technologies support rollback and rolling updates across high availability environments. This isn't natively supported by Terraform, but organizations can architect and develop their own practices to support these. It is, if you version control your infrastructure as code, you can roll back to previous versions. You would just have to automate that through your CI/CD pipeline or some other means of automating that rollback capability. In addition to lack of native rollback support, conditional logic can be difficult to implement within the Terraform configuration files. And this is because the HCL uses a declarative syntax. And in the future, people I've talked to at Terraform, they're adding in improved conditional logic support, but I haven't seen it yet. And so conditional logic can be harder. I will show you some examples, or at least talk through some examples of how you can implement workarounds to do some of that logic. I mentioned providers before, and there's a wide variety of providers across cloud, infrastructure as a service, platform as a service, software as a service, but there's also on-premise services and technologies. And beyond the officially supported providers, there's customers can create their own providers. They can leverage providers created by the community that may not be part of the official repository. Just beware with any third-party code, third-party providers. You need to make sure that you review those and that those are that there's nothing malicious about those providers. And so take a look at those the ones from the official repositories are less likely to have those issues because they're leveraged by other people that are hopefully also reviewing those. But there's providers for firewalls, Palo Alto, Fortinet, Cisco. There's providers for VMware, anything that has APIs that can be used to modify the state of resources. You can build a provider with Terraform to manage those resources. And like I said, there's over 100 different providers already available. Provisioners are used to allow Terraform to execute specific commands, agents, or actions as part of resource creation or destruction. And so you can use, for instance, the local exec to run commands from the machine that's running Terraform, and then you can connect to different resources and make changes. You can use remote exec to connect to the resource itself once it's created and run commands and install things, similar to, if you're familiar with like user data in the AWS CloudFormation, where you can run commands on a remote resource. You can install, configure, and run the Chef client on a remote resource to kick off the Chef configuration as code or configuration management once the resource is created, copy files, and then null resources can be used to configure provisioners that aren't associated with a single resource. If you want to run a local exec that is a script that modifies the environment as a whole or a bunch of different resources within the environment, you can put that within a null resource, and then you can have that script run as part of that null resource creation. The command line interface is used to, initialize, create the execution plan, apply changes to the environment, destroy the environment based off of your configuration. You can also import those existing resources that I talked about. Taint and untaint will mark a resource for modification even if the changes, even if Terraform deems that changes are not required. It'll look at it'll refresh the state of the item when you run the plan, Terraform plan, and it will compare your configuration file against the state files that exist and determine if there are changes. But for null resources and certain types of resources, it can't always figure out that a change is needed because, for instance, in a null resource, most of the time you're just writing some script, some code. And so you can taint that resource, which causes Terraform to rerun those scripts the next time you do a Terraform apply. Now let's look at some of the basics of the HashiCorp configuration language. First, we have input variables, and this is how we pass information to this is how we parameterize Terraform configurations. Terraform supports 3 main variable types as demonstrated on this slide. There are strings, lists, and maps. Strings are simple and define a single key value mapping with the key being the variable name. Lists accept or define a list of strings. The strings are indexed starting with 0 and can be accessed via the element built-in function. So you'd write something like element, in this case, location, comma 0, and that would return central US in your configuration. Maps contain multiple key value pairs and can be accessed via the lookup built-in function. So lookup, subnets, development would return 10.1.1.0/24. And this is how you can parameterize your configuration files, and then maps allow you to look up values based on maybe some other input. If you're passing in the environment that you're deploying to, development or production, then it can dynamically use the map to look up the IP ranges that it should be using. For setting and passing variables, there are a few different ways to do this. We can use environmental variables. If we set an environmental variable with tf_var_, and then the variable name, that will get passed in when we run Terraform plan or apply or destroy. And then variable files can also be used. and so you would name the file name .tfvars, and then you would specify the command line option -var -file, and then you would pass in the file name with the .tfvars extension. It would be a list of key value pairs, and that would be fed into the configuration when you run plan or apply, if you pass that in on the command line. If you have multiple files, you can specify them. If they have the same variable name defined, the last one wins. And so you can pass in multiple files, they can have duplicates, the last one wins. And then -var is to pass those in the command line, and you would just pass in after the -var the variable name and the variable value. So in the case of the examples we'll be looking at, resource group, resource_group equals DevSecOps. And then also, if you don't define these, it will just ask for input when you run your plan or apply. It'll ask you to input the values for those variables, unless they have a default value, and then it'll just use the default value if you don't provide it. Here's an example of a provider. You can pin to a specific version number, which is for sure recommended in your production environment. You don't want a new version of the plugin to be released and not be backwards compatible or have some issues, and all of a sudden now you're broken in production because you are getting the latest version. So for production, maybe you pin to a specific version. For dev and test environments, maybe you let it get the latest just so you can test out the new version. There may be new features that you need or want to look at. And then it would give you an early warning sign that you're going to have problems when you upgrade that version if some of your tests start to fail. Then you can define the different credentials for authenticating to, in this case, Azure, in the provider block as well. You can pass those in as variables, but you don't have to do this. You can use environmental variables, and in the case of Azure, it's arm_client_ID, arm_client_secret. And so if you set those environmental variables, you don't have to have these defined in the provider. You can hard code these, but obviously from security perspective, we don't want to hard code credentials in code. If we commit those to Git or some other repository, then other people have access to those. And so we want to avoid that. That's something we want to look for in our audits, is there shouldn't be any hard-coded credentials. We can pass them in as variables or set environmental variables instead. The above resource examples create an Azure resource group, which is the Azure RM_resource_group, and an Azure container registry. DevSecOps is the name of the resource, which must be unique per resource type. So this is a unique name for that resource that's just used to reference the resource in other resource configuration blocks. And you can see that in the container registry under resource group name, we're just pulling the Azure resource group DevSecOps name property. Now the name of the resource group will be what we pass in from the variables. So the input variable we pass in resource group will define the actual name of the resource group in Azure, but the name that we use to reference that resource group within our configuration code is the DevSecOps in this case. And you'll see that it's not unique across different resource types, but it does have to be unique for a single resource type. We couldn't have another resource of Azure RM_resource_group with the name DevSecOps after it. It would have to be unique. Data sources are used to get information about resources that are not defined or managed by the current configuration. In the above example, the first data source is querying for information about an Azure container registry, and then the second data source uses the resource group name property from that data source to query for information about the Azure Kubernetes cluster. And these data source properties can be referenced to get information about to get information and to set properties for other resources. Data sources are used when, for instance, maybe you're not managing those resources within this Terraform code. Maybe there's some other Terraform code that's managing those resources, or they're just unmanaged resources. You can still pull in that information into your script. So it's read-only access to, in this example, the Azure APIs to pull back that information. And the difference between the example that we saw before and this example is that when we define this, when we reference this property, it has data in front of it. Whereas if you're referencing a resource, it's just you start with the resource type. Here's an example of a null resource. And the reason that I've used this null resource in particular is when creating a Kubernetes service and deploying containers to it, there is a way to create a container registry, but there's not a way in Terraform to build a container, like to push the code and build a container in the container registry. And so instead, what I'm doing here is running AZ login to log into Azure, and then running an AZ ACR build from the command line, which will push up that code and then build that container. Once you have defined all your resources and set up your configuration, when you run Terraform apply and it creates all these resources, you may need to get information back about those resources you created, and that's where you would use outputs. Outputs define the information that needs to be returned from the configuration run. In this example, from the container registry, we want to return back the container registry URL. So we know where to log into that container registry. And we do that by specifying the resource type, the resource name, and then the property that we want to return from that resource. Now briefly, we'll take a look at the Azure Kubernetes service, because during the demo, we're going to go through some basic Terraform, but then I'll also show you a more complex parent-child relationship that I've set up where you can deploy and set up an Azure Kubernetes service. The Azure Kubernetes service is a fully managed Kubernetes container orchestration platform built on Azure, and it leverages open source Kubernetes without customizations. It can be integrated into Azure Active Directory for role-based access controls, and can also leverage Azure Key Vault for storage and protection of cryptographic keys and secrets. The service can be managed through the portal, through the CLI, through Azure Resource Manager templates, and then obviously Terraform. And it also supports installation and use of other plugins and services to automate software delivery. The Kubernetes service has clusters. So the cluster itself is the master and all of its nodes that it uses to manage and run and orchestrate your containers in your environment. A node is a worker machine, formerly called minions, or even earlier than that, Borglets. And this is where your containers run. And it's built by node running on the cluster. So these nodes are persistent. They live for the life of the cluster, and you're built by those nodes. The virtual node is a virtual worker, and this is a node that's dynamically provisioned, and it's built by execution time. You can have a base set of nodes that are just always there to run your containers, but if you need to spin up a node temporarily to run some containers, you can use virtual nodes. A pod is a way of grouping containers to share resources, and that's where these resources are co-located and co-scheduled. So it kind of groups those container resources together. And then a service defines policy on how to access, set up access to pods. For instance, you can have like a front-end service. They can be used to help like a front-end service identify the back-end service that it needs to use. Service principals are similar to, if you're familiar with roles in AWS, where you can have resources assume roles. That's what a service principal is. It's like a service account that these applications and resources can get permissions to do things. And then you can use role-based access control, HTTP application routing, virtual networking, Azure Monitor. These are all additional Azure features that can be integrated into the service. Here's an example of the Kubernetes service Terraform. We have our resource group and then our cluster, and we begin to define out that cluster and set the name and the DNS prefix and some other values. And then we have the profile to set up the Linux nodes and define the details on the type of instances we want to use for our nodes, the count. In this instance, in this example, we're just using one, but in most production environments, you'd have at least 3 or more of those in your pool. And then we've assigned a service principal and a tag. So now let's dive into a demo of some of the basics of Terraform. Let me pull some windows over so that you can see them. All right, give me a second to get this over. Here we have a very basic Terraform file, and it's just called main.tf. And we have up at the top a provider, and I've commented everything out because I'm going to use environmental variables to set these values. And then we have some variables. We're going to pass in the resource group name and the location. And the location has a default of Central US, so we wouldn't need to set that unless we're changing from the default to something else. Here we have the resource group resource that we're going to be creating. So this is actually going to create a resource group in Azure. And then we also have our container registry. And this references the resource group that we've created, and then also the location that we used. And by referencing this here, this sets an implicit dependency on this resource group. So this resource group has to exist before creating the container registry because we've referenced properties. You can do explicit dependencies with the depends on, and you can pass in a list of dependencies. And that has to be written as a list, even if you just have one dependency. And then the output is the container registry URL. So it's similar to what we went over into the slides, but now we're going to actually create these resources. In order to demonstrate, though, the import functionality, I'm going to go ahead and create a resource group in the Azure portal. So I could do this from the command line, but I'm just going to create this resource group so that we can look and see how the import works later. All right, now we have our resource group. In Azure, the resource group is what is used to kind of organize all of your resources and manage those. Even though you do have to assign a resource group to a specific location within Azure, it can be used to manage resources across all locations. And so really it's just a bucket for organizing those resources. It can be used to look up billing information for those resources, but also if you delete a resource group, it'll delete all the resources in that resource group, even if they're spread across multiple locations. Now that we have our configuration file, we need to run some commands. And the first one that we're going to run here is Terraform plan. Oops. Hold on, let me get back here. Now this is going to error out. and I just wanted to show you so that if you see this in the future, you're aware. You can't run Terraform plan before you run a init. What a init is going to do it's going to download the plugins that you need. We're using the Azure RM provider. We need to download that. All right. And so now we have our Terraform environment initialized, which means we downloaded that provider. Now we can run our Terraform plan. And this time I'm going to output that to a file to save the execution plan. And I'm not going to pass in any variables. It's going to ask me for the resource group. And I'll just call this DevSecOps. Oh, first we need to set up the credentials. We don't have credentials. And so what I'm going to do here is I've assigned this environmental variable with the name of the service principal we want to create. And then we're doing an AZ login, which is an interactive login to get the subscription ID. And then using that information to create a service principal. And then we're pulling back the client secret from the service principal command. And then we're running some other commands to get the client ID and the tenant ID. And then TF-var, client ID and secret are used because we are then using this. So these are set later if we have time to do the Kubernetes service to set up the service principal for that code. So we have to also pass those in because they're not just being used for the provider. If they were just being used for the provider, then we wouldn't need to pass those in. Here's our interactive login. And now that we've authenticated, it's creating the service principal and granting it access to our account, which takes a little bit of time. And now we'll run our plan. All right. Apologize, let's see. Oh, so somehow some extra characters got in there when I was waiting for it to respond. So we'll run that again. And now you'll see that it's going to create two resources. But we know that we already have a resource group. We already created a resource group called DevSecOps. However, if we look here in the directory, there is no TF state file. So when Terraform runs a plan, it's comparing what's in the TF state files against your configuration code, which is in my main.tf, and it's determining what needs to be created based on the differences between those files. Since we don't have any TF state, it doesn't know about that resource group. In order to create that, we need to run a Terraform import to import that resource, and then that will create the TF state file in order to get that. So let me grab this import command. And so what we're saying is we're going to import the Azure Resource Group basic example, which is what it's named over here. We're going to import that based off of this resource ID. So we're giving the fully qualified resource ID for that resource that already exists. And it's going to import that resource and assign it to the basic example resource that we have in our configuration file. Now, if we take a look, we do have a TF state file. If we come over here and look at it, here is our basic example resource group, and it has all of the details of that resource as it's set up in Azure. Now that we have that in the TF state, if we run Terraform plan again and pass in the same name, you'll see that now it's only going to add one resource. It's only going to add the container registry because that resource group already exists. Now let's apply this. And you'll see that we added one resource, and here is our output. Our output is devsecops cr.azurecr.io. And so that's the login server that we use for logging into the container registry. We would need to also pass back the username and password, which I left out, but we would need to output those as well to allow us to then log in, or we can query that to we can query Azure with credentials to get those credentials to log in the future. Now that I've created this, let's go look in the portal for our container registry. Here's the container registry that we created. And then if we're creating, for instance, environments that are short-lived, maybe for testing or even in production, we redeploy frequently, we can tear down this infrastructure with Terraform Destroy, and it's going to take those two resources that we created and remove those from Azure. Pass in our resource group name. It'll confirm that we want to destroy those two resources, and we'll type yes. And then it will remove those resources. Now, while that is running, let's take a look at a more thorough example of Terraform. And this one uses parents and children. And so we have this parent module that then references child modules. Here we have the provider, Azure Resource Manager. We are pinning to a specific version. And then we have different modules. So this first module sets up the base resources that we need. This second module is going to run that null resource that deploys the ACR, the container to the container registry. And then this final one is going to set up the containers. So this base one, the resources, is going to set up the actually this one is all the Kubernetes stuff. So this is the base one is going to set up all of the regular resources like the resource group and a few in the container registry and a few other things. And then this kube module will set up the Kubernetes cluster and deploy the container for the application to that cluster based off of the build that we set up in this module here. Now, as you can see here, we don't have everything in the main.tf like we did previously. We have a separate variables file, and we have a separate outputs. And so this is one way of defining modules, or at least it's the way outlined in the Terraform documentation. And so here you have the variables. One thing to point out is here is a way of doing what they don't have is in some of the other infrastructure as code providers, you can do some validation of the variables so that you can tell people, hey, we only accept these values for these variables. That's not easy to do in Terraform. It can be done, and this is an example. Here we have a list of locations that are supported, and then we create a null resource with a name. We just give it a name, and then we make sure that the location that's passed in is within this list of locations. If that's true, then we set count to 0, and this is how you do some conditional logic. This is the workaround for conditional logic, is using this count property. And so we set count to 0. If the location is not in that list of locations, we set it to 1, and then we provide an error back to the user. Hey, you have to make sure that the location's either central US or West US. The different modules that we define here are folders. So the source here references the folder where these modules are stored, and then we can go in and see the different variables that are required, the outputs, and the code that actually creates these resources in the children. And so that's how you would set up a bigger environment with Terraform, is typically by using these modules. And modules also allow you to reuse code. And so your kube module for creating Kubernetes clusters and deploying them, if that's set up correctly with the right variables and things, you could use that across many different environments. So it's a way to compartmentalize different types of infrastructure as code. And so with that, before we get to questions, I have a few other things to mention. Sec 540 has been updated. It has an updated title, so now it's called Cloud Security and DevOps Automation. It used to be called Secure DevOps and Cloud Application Security. And this more accurately reflects both the course content and the students that we want to attend the course. It also has new bonus challenges, NetWars bonus challenges, days 1 through 4 from 5 to 7 p.m. So these are challenges that you can go through that walk you through more information on usage of Git, usage of Terraform, some Azure content, Azure CLI content. And then we've also added some slides on Azure and Terraform and Kubernetes. And then there's also a challenge coin associated with these bonus challenges. So similar to some of the other classes that have challenge coins, 3 students that score the highest on the bonus challenges will get a challenge coin, and then also there's stickers for the people that participate. There's the Cloud and DevOps Security Summit and Training in Denver in November, so look out for that. And also there are some other webinars that are going to be put on by the other authors and instructors for this course. So look out for those. Frank has already presented his, but there's an archived version of that if you want to go take a look. And so now I'll turn the time over to everybody for any questions they might have.
All right, thanks for that great presentation. Currently, no one has submitted any questions. So if you have a question for David, please enter it into the questions window now. In the meantime, I'd like to remind everyone that you can find your CEUs for all completed webcasts by logging into your SANS portal account. Navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the web page. All right, we had a question come in. They asked, what is the difference between 540 and 545?
Good question. So 545 is going to cover a lot of the CSA guidance, the Cloud Security Alliance guidance, and it's going to be more focused on, or at least the labs and things, you're going to be using some of the CLI, but primarily the web interface for interacting with AWS, where 540 gets more into the automation. And so within 540, you're going to be spending some of the time using more on-premise type technologies like Jenkins and GitLab and some of the other on-premise technologies. But then the rest of the class is AWS Cloud. I mean, we cover some Azure Cloud content, and in the bonuses, there's some Azure and Terraform stuff, but the classroom time is spent with AWS. We're using CloudFormation, we're using Jenkins, Blue Ocean to define pipeline as code. So it's very automation heavy and really more focused on, you know, how you would do cloud in a more DevOps manner.
All right, thanks, David. I haven't seen any more questions come in. Do you have any closing thoughts you'd like to share? Oh, I'm sorry, one just popped in.
Okay.
What's the level of base technical knowledge needed to be successful in Sec 540?
You know, the labs are really well defined with step-by-step procedures. And so while it is difficult for some students that don't have a development background, they've all been able to get through it. So we will help them get through, and it's nice because the VM provides a full CI/CD environment to do deployments. It's containerized, and you have Jenkins and GitLab and Vault and Grafana and a bunch of tools on there that help you understand, even if those are not the technologies you're using, help you understand DevOps better. And like I said, the labs they have the step-by-step guidance, so it's not like you're going to have to be creating this code on your own. Because of time constraints, most of the labs we're just having you merge the fixes in. There's a few labs where we have you have the option to do the changes manual if you'd like, but most of the time we're merging in. And then the students can still use that VM after the fact to do things in more of take a manual approach or not follow the step-by-steps to continue to learn. But because of time constraints in class, most of the students are using those step-by-step instructions anyway. So I hope that answers your question. If not,
yeah,
let me know. You can reach out to me. I gave my contact information at the beginning, but I'm easy to find. My name's pretty unique, so just reach out to me on LinkedIn or wherever, and I can give you some more details if you have more questions.
All right, that looks like everything. Any last words, David?
No, it's really fun to see all of the technologies that are available now, and with cloud, all of the things that you can mess around with. Like cloud makes things more accessible for just the average person. Like for instance, you're not going to go out and get an Akamai CDN to mess around with, but because of cloud providers, if you want to test out using a CDN, doing signing in a content delivery network, you can do that. And same with all this automation technology. It's really exciting to see the direction we're moving and all the capabilities that we have of making things repeatable and more structured, so that we don't have the problems that we have had in the past.
All right, well, thank you so much, David, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.